Okay, now we're going to start looking at net ionic equations. We talked about single replacement reactions and how we knew if a reaction would occur or not based on the activity series of metals. Well, when it comes to double replacement reactions, we have to look at solubilities. That's what's going to tell us if a product is formed or not. Now you see this reaction up here, and this is obviously a double replacement reaction. You have silver nitrate, which is aqueous, which is dissolved in water, and sodium chloride, which is also aqueous. It yields silver chloride. Notice the silver chloride is a solid. That means it is a precipitate. A precipitate is a substance that falls out of solution, which basically means when the two react, it becomes a solid and falls out of solution as a solid. And the sodium nitrate here is still going to be an aqueous solution. Okay. Let's look at this next one. Let's look at this reaction. Okay. When you have a reaction like this, first we have to look at solubilities. We're just going to assume right now, looking at this, we know exactly what's happening. We're going to assume a reaction does occur. So, if I look at this, if it's aqueous, if it says AQ up here, I basically split the cation and the anion in half. So I make it AG plus 1, and it's aqueous, plus NO3 minus 1 aqueous. You see how I split those two apart? I split the silver and the nitrate. This is the positive, that's the negative. I just now split them apart because in solution they are apart. Remember, water is a home wrecker. Plus my sodium, Na plus 1 aqueous, plus Cl negative 1 aqueous. So these two split up as well. Now we come to this next part. This is solid. So what's going to happen is this is not going to split up. It's going to stay AgCl solid because it is not coming apart in the water. But you have sodium plus 1 aqueous plus NO3 minus 1 aqueous. So basically I'm just splitting apart anything that's aqueous. So far so good. Now, what happens is this. Whatever is the same on the reactant side as the product side, I basically get rid of. Silver plus 1. Oh, there's no silver plus 1 over here, so I can't get rid of that one. NO3 minus 1 aqueous. Right here, NO3 minus 1 aqueous. I cancel them out. Na plus 1 aqueous. Na plus 1 aqueous. I crossed it out. Cl minus 1 aqueous. Not on this side. Whatever is left behind is my actual reaction. Ag plus 1 aqueous plus Cl negative 1 aqueous yields AgCl solid. This is the reaction that's going on in that test tube. This is the actual reaction I am looking at. Okay? And if I want to look at it like this, basically here it is kind of nice and neat for you. I've crossed off my sodium and my nitrates on both sides. These elements that are crossed out, or the substances that are crossed out, are called spectator ions. They do not participate in the reaction at all. They're just spectators. Just like going to a baseball game or basketball game, you're considered a spectator. You have no input in the reaction whatsoever. Whatever happens to that game, it's really, you have nothing to do with it. You're a spectator. These guys here have nothing to do with the reaction either. This is what we call a complete ionic equation. All of this. This is complete. But I don't really care about a complete ionic equation. I want the net ionic. This is my net. This is what's actually happening in the reaction. This is my reaction. The sodium and the nitrate are still floating around in the water somewhere where the silver chloride is at the bottom. Let's try the next one. Okay, so now we have lead, solid, so we just leave it Pb, solid, plus silver nitrate. It's aqueous, so we're going to split it in half. Ag plus 1, aqueous, plus NO3 minus 1, aqueous, yields Ag solid. Remember, you only break apart the aqueuses. Pb plus 2. How do I know it's a plus 2? Right there. Aqueous plus, how many NO3s do I have? I have 2 NO3s. Well, I guess it would have helped if I would have balanced the equation first, right? So I need to balance it. So I'm going to put a 2 here and a 2 there. And that will balance it for me. So I'm going to put this 2 here, and I'll put a 2 there, and I'll also put a 2 here. So there's 2 silvers, 2 nitrates. Now I go through and I look at this. My lead is basically neutral on this side. It's not neutral, so that stays put. 2 silvers. This is a plus 1. This is 2 silvers, the actual metal. Can't get rid of that. My only spectator ion is my NO3. So my net ionic equation would be Pb, solid, plus 2 Ag plus 1, aqueous, yields 2 Ag plus, I'm sorry, get rid of that plus 1. I didn't need that at all. My bad. Okay. Solid plus Pb positive 2 aqueous. Okay? This is my net ionic equation. Okay? Let's see. Now let's talk about solubilities. Let's try to predict if we can actually tell what's going to happen or not. Okay. When I look at this reaction here between sodium carbonate and barium nitrate, will an actual reaction occur? You guys gotta remember, when I put these into a beaker, I take, here's one beaker with the sodium and the carbonates all floating around, minus 2, plus 1, Na plus 1. They're all floating around in the water. Okay? And I add it to another aqueous solution of barium floating around in the water and NO3 floating around in the water. These guys are just floating around as ions. Now, when they get together, what happens, the barium wants to go and hook up with the carbonate, and the sodium wants to hook up with the nitrate. What's going to happen? Let's look over here. Okay, salts of all alkali metals and ammonia are always soluble. Soluble means it dissolves in the water. Okay, so salts of alkali metals are your first group, so your sodiums will always be soluble. So we know this is going to be soluble no matter what. It's going to dissolve in water. Let's look for the barium. Barium here, okay, sulfur salts accept compounds with lead, silver, mercury, barium are soluble, except these. So this is going to be insoluble. That's going to be my solid at the bottom. So what's going to happen is this. In my beaker at the end, I'm going to have sodium and nitrate floating around in the water, and down here at the bottom is going to be a thick white substance, a solid, that's going to be barium carbonate. It's going to be my precipitate. Okay? So let's do the reaction. The net ionic equation here. We said this is aqueous, so we're going to split this in half. Let's first make sure it's balanced. That'd be a good thing. It's not. Let's put a 2 there. Give me 2 sodiums, 2 sodium. Okay, it's all ready to go. So I write 2 Na positive 1 aqueous. How do I know it's aqueous? Because we started off with aqueous solutions. Plus CO3 minus 2 aqueous plus, this is aqueous 2. Remember I told you we had 2 aqueous solutions. Ba plus 2 aqueous plus 2NO3 minus 1 aqueous. Now, we said the barium carbonate would be our precipitate at the bottom. So, barium carbonate stays together as a solid. Okay? And then we have 2Na positive 1 aqueous plus 2NO3 minus 1 aqueous. Let's cross off our likes. 2Na, 2Na, and 2NO3, 2NO3. These two have nothing to cross off with. So my net ionic equation is Ba plus 2 aqueous plus CO3 minus 2 aqueous yields BaCO3 solid. My net ionic equation. Okay? Now, if you look at this, once again, this is our activity series of metals. We use this for our single replacement. We don't use this for our double replacement. We use the solubility charts. And the solubility chart looks like this. And basically it shows you here that barium is aqueous in a lot of things, but barium carbonate right here is a solid. I lied. Right here. Barium carbonate's a solid. Calcium carbonate's also solid. Look, most of your carbonates are solid unless they are your alkali metals. Alkali metals. Alkali metals. Okay? I'll teach you how to read those, and then we'll keep work on them in the classroom. Okay, so let's look at this. Let's practice a couple of these. Sulfur trioxide and water form to make sulfuric acid. Try these and we'll go over them in class. Okay? Actually, yeah, we'll go over them in class. That way we can make sure we know what we're doing there. And remember, sulfuric acid is H2SO4. And it is aqueous. Okay? I'll see you soon.